Alright, in this video we're going to go over some problems that involve similar triangles. So the first question here says, Kyle performs a transformation on a triangle. The resulting triangle is similar but not congruent to the original triangle. Which transformation did Kyle perform on the triangle? So here you need to know what the definition of a rigid motion is. A rigid motion results in congruent figures. We do not want the figures to be congruent, we only want the figures to be similar. So that means they need to be the same shape, but not the same size. If we look at our choices here, reflection, rotation, and translation are automatically out because those are three rigid motions, which means they always result in congruent figures. So the answer is A, dilation, because when we dilate a figure, we're making it either bigger or smaller. So dilation is a non-rigid motion that results in similar figures. All right, the next one here is a proof. So this says that James correctly proves the similarity of triangles DAC and DBA as shown. So here we have a picture and we have a proof with most of all of our statements filled in, and we're missing one reason. So the question we have to answer is, what is the missing reason for the seventh statement? So let's look through the proof and see what the seventh statement is asking us so we can justify it with the correct reason. So to start, our given is that the measure of angle CAB, so if we look at our picture here, let's find CAB, so CAB is right here, it's a right angle, is equal to the measure of angle ADB, and both of those angles equal 90 degrees. So we're just confirming that the angles that are marked as right angles are actually right angles. Now they tell us the measure of angle ADB, so this angle right here, plus the measure of angle ADC equals 180 degrees, because those angles are a linear pair, which means they form a straight line and they are supplementary. So if we know that they are supplementary, they have to add up to 180 degrees. That means that angle ADC also has to be a right angle. So I'm going to draw that in there. And here you can see statement 3, we use substitution to replace the measure of angle ADB with 90 degrees. And then we subtract that 90 from both sides to find that the measure of angle ADC is in fact 90 degrees. So now we can mark that with a right angle. All right, so now we are told in line 5 that angle CAB is congruent to angle ADB. Well, we already knew that because those are both right angles. So since their measures are equal, we can say the angles are congruent. That's by the definition of congruent angles. Same thing for angle CAB and angle ADC. They both measure 90 degrees. So the definition of congruent angles tells us, hey, if both of those angles measure 90 degrees, then the angles themselves have to be congruent. Next, we use the reflexive property to say that angle ABC, so angle ABC down here, is congruent to angle DBA, which is also right here. So that's just saying that, hey, this angle is congruent to itself. Same thing here, triangle, oops, sorry, I skipped a step, angle DCA, so DCA, this angle right here, DCA, is congruent to angle ACB. So again, that's just naming the angle two different ways. It's saying that angle is congruent to itself. Now, what we need to figure out is, why can we say that the triangles in this picture are similar? So the problem says that triangle ABC, which is our big triangle here, is similar to triangle DBA, this smaller triangle down here. So since we're trying to say that triangles are similar, we only have three choices. We can use side, 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 angle, or angle, angle. Those are our three triangle similarity theorems or postulates. So if you know that, you can automatically say the answer is B, because angle, angle is the only similarity theorem that is here. Let's look at why the other answers are incorrect. Here for A, CPCTC, Remember, that means corresponding parts of congruent triangles are congruent. You can't use that until after you've established similar triangles. So that is out. All right triangles are similar. That's something that we've never talked about, so that's out. And then the transitive property of similarity is not a property of similarity that we've talked about. So here we know the answer has to be the angle-angle postulate. All right, this one, two triangles are shown on a coordinate grid. So here we have triangle ABC, and then we have triangle EDC. Katie shows that the two triangles are similar. So we know that the big triangle and the little triangle are in fact similar. I'm going to move this blue off for a second. So we know that triangle ABC and triangle EDA are similar. She performs the following series of transformations to prove that they're similar. So, first, she rotates triangle ABC 180 degrees about point A. So, if you were doing this problem, you had tracing paper available to you when you were doing this problem, or if you haven't done it yet, tracing paper would be available to you. So you want to make sure that you actually take advantage of that and utilize it, because tracing paper is really going to be helpful here. If we start with triangle ABC, and we want to rotate it 180 degrees about point A, that means point A is not going to move. So we need to do 2 complete rotations about point A. And your resulting figure would end up here when you actually do that correctly. It's a little hard to see on the computer here. Again, tracing paper, when you rotate this triangle ABC 180 degrees about point A, it ends up right here where this blue triangle is. Then Katie dilates triangle A prime, B prime, C prime. So remember, after we perform a rotation, we have a transformed figure. So we label with primes, A prime, B prime, C prime, by a scale factor of K with a center of dilation at point A. So we need to figure out what K is. How many times bigger did this blue triangle get? Well, if I look at this bottom piece right here, I can see that it is 4 blocks long. In the big triangle EDC, the corresponding piece is 8 blocks long, which means the triangle got 2 times bigger. So our scale factor is K. Now, after we dilate the triangle, she also moves the triangle. She translates it. P units to the right and Q units down to map onto triangle CDE. So this red point, point A, needs to end up where point C is. So if we move 4 units to the right, 1, 2, 3, 4, and 3 units down, my red points will match up. So if P is the number of units we move to the right, the answer is 4. And then we move 3 units down, so Q is equal to 3.